Today we're going to take notes on division again, but we're going to look at an expanded notation model. So this is just another tool to use. It's very similar to area models. So we're going to show you how that works. So we're going to go to our table of contents and write the date, 7/27. We're going to write division, expanded notation, and for me this is page 12. And I forgot to add the objective number for our last few things that we've entered into our table of contents. So I'm just going to go right now and ask you guys to go ahead and update your objective numbers. For standard algorithm practice on 7/25, that should have been NBT 5. For last night's notes, so 7/26 division area models, that should be MBT 6. And then tonight's notes are MBT 6. All right, so we're going to go ahead, turn to the next page, and at the top we're going to write division, expanded notation, all right, and we're going to get started. We're going to start with the same problem we had yesterday. So we're going to start with 378 divided by 7. We're trying to figure out what that equals. Now this number here, remember, is called the dividend. Okay, and this number here is called the divisor. And this last little part here, our answer, is called the quotient. Remember, the dividend is the first number because that's the number that goes in the house if you do it the long division way like this. That's why it's called, that's how I remember that it's called the dividend. The divisor goes outside the house, and the quotient always goes on top of the house, if ever you see it like that. Okay, we're going to look at expanded notation method. So I still put my 7 out here. And this time I'm going to make a rectangle, but I'm going to make it a little bit longer than I normally do. So I'm going to put 378 here. Again, I am not sure what I can multiply 378, or excuse me, what I can multiply 7 by in order to get an answer of 378. I don't know how many times 7 fits into 378. I'm trying to figure out how many groups of 7 are inside of 378, and I don't know. Okay, but I do know that 0 is a powerful number. I do know that whatever I multiply 7 by, I can put a 0 on the end and I can increase it. So the first thing I need to think about are my basic 7 facts. I know that 7 times 5 is 35. And if I put a 0 on the end of that 35, I get 350, which is really close to this. So if I think 7 times 5 is 35, how would I get a 0 on the end? I would add a 0 to the number that I'm multiplying 7 by. So 7 times 50 then is 350, because the 7 times the 5 gave me 35, and then I add my 0 on the end. So I subtract. 8 minus 0 is 8. 7 minus 5 is 2. Now, instead of making a new box here, I'm going to look at how many times will 7 go into 28. How many 7s are inside the number 28? Or how many 7s does it take to make 28? Well, it takes 4 7s, or 4 times 7. So right above this 50, I'm going to write a 4. Kind of draw a little line here so it separates those two things. But right above this 50, I draw a 4, and 4 times that 7 is 28. So I subtract 28 down here, and I get 0 left over. Now I have to, these are still partial quotients. So both of these right here are partial quotients. So I still have to add those together. And when I add them together, I get 54 as my quotient. Okay, so this is my answer, and the answer to a division equation means your quotient. Okay. Now we're going to look at the paper chains problem again. We've already done cubes with it, and we've already figured out what we need to do. So we're going to use expanded notation to solve that paper chains problem again and see how it looks in a different format. So we know that we have 1,446. This is the problem from yesterday, the paper chains problem you were working on yesterday. 1,446 divided by 8. We're splitting this many strips of paper with 8 teachers, and we need to know our answer. Okay? I want you to pause the video and try to name what each of these parts of the equation are. Try to tell me the math name for this number, the math name for this number, and the math name for this number. When we're looking at division, what do we call each part of the equation? Okay, so pause the video, try to label those. So this is called our dividend. This is called our divisor. And this is called our quotient. Alright, we're going to start. So we put the 8 on the outside. We draw a longer box than normal. We write our dividend on the inside, 1,446. Now I've got to think, how many times will 8 go into 1,446? Whoa, that's a big number. But what I do know is that 8 times 1 is 8. And if I add 2 zeros to that, then I get a much bigger product when I multiply those two numbers. So I get 800 that I can subtract. Because if I have 108, it makes 800 right here. Alright, so 6 minus 0 is 6, 4 minus 0 is 4. Here I can't take 8 away from 4. I don't have enough to take 8 away. So I have to make this a 14, and this turns into a 0. And 14 minus 8 is 6. So I have 646 left. Now, I have to think, how many times will 8 go into 646? Well, I know that 8 times 8 is 64, and if I put a 0 on that, that makes 640. So if I do 8 times 8, 64, but I want to get another 0, so I can put a 0 right here. So 8 times 80 is 640. 6 minus 0 is 6, 4 minus 4 is 0, 6 minus 6 is 0. So I end up with 6 left over, and this number is called my remainder because it is smaller than my divisor out here. When you get a number down here that's smaller than what you have in your divisor, then it's definitely going to be your remainder. So now I have 100 plus 80 because these are partial quotients up here. So I get 180 as my answer. Or another word for the answer to a division problem is a quotient. And that's how you do expanded notation. It's very similar to area models, except you're putting your numbers up top versus across, and you're keeping track of all your math right here in one box. Okay? Silly saying for today is, let me think of what would be a good one. I want you to be able to come in and tell me one way that we can soar in the hallway. See you guys tomorrow.